Okay, today we are going to finish section 7.4, focusing mostly on this part here, the value of the derivative and the behavior of the graph, and we're going to focus today on drawing those sign charts. So in order to make good sign charts, we need to remember a couple things. When my graph is increasing or strictly increasing, generally going upwards, remember we're focusing on the strictly increasing where the value of the derivative is positive. And with decreasing and strictly decreasing, the same thing. It's generally going downwards. We're focusing on the strictly decreasing where the value of the derivative is negative. Okay, so let's look at this one from your homework from Monday. All right, if you look at this, it has two decreasing intervals. It is decreasing here, and it's decreasing right here. And we have two increasing intervals as well. It is increasing right here, and it's increasing right here. So that means that we need a critical number for the beginning and or the end of each of those. So when we get ready to draw our sign chart, I can see that I have one value, one critical value where the derivative is actually equal to 0. That's that minimum value that occurs at 2. And then I can see that I have two critical values where f of x is undefined, or f prime of x, sorry, is undefined. That's where I have my asymptote. So I have one at 0, so I'm drawing a dotted line for that, and I have another one at 4, so I'm drawing a dotted line for that. Okay, well, where I've colored over my function blue, that's where I can see that the function is decreasing. So that means that to the left of 0, the value of my derivative must be less than 0. It must be negative because my function is decreasing. All right, in between 0 and 2, again, the value of my derivative must be less than 0. It must be negative because the function is decreasing. In between 2 and 4, I switch. In between 2 and 4 now, I'm going in an upwards direction. So the value of my derivative must be greater than 0. It must be positive because the function is increasing. And after 4, it's still increasing. So the derivative of my function must still be positive because my function is still increasing. So 0 and 4 are neither maximums nor minimums because they're asymptotes. However, at the point where x equals 2, I can see that my function is decreasing and then increasing. So 2 is going to end up being a minimum. I would label that as a minimum of the curve. Okay, let's try another one. So I have this one. All right, so if I draw my sign chart, let's see what's happening here. I can see that I have a maximum value at -2, and the derivative actually exists there, so I'm going to put a solid line. I can see that I have an asymptote at -1. The derivative is undefined there, so I'm going to put a dotted line. And then I also have a minimum value of 0, and my derivative again actually exists there. I have a minimum value, so I'm going to put a solid line. Okay, so now let's talk about increasing and decreasing. All right, so on this side of -2, I can see that my function is increasing. As I move from left to right, it is going up. So that means that my derivative must have been greater than 0. It must have a positive value because my function is increasing. All right, now this part, in between -2 and 1, I can see that my graph is going down, it's decreasing. So that means that the value of the derivative must be less than 0. It must be negative because my function is decreasing. All right, now once I get to the right of -1, I'm right here, in between -1 and 0. Again, my function is decreasing. So that means the value of the derivative must be less than 0. My function is decreasing, the value is negative. And then on this side of 0, on the right-hand side of 0, I can see that my function is going up. So therefore, the value of the derivative must be greater than 0. It must be positive because my function is increasing. Okay, so just like last time, -1 is not a minimum or a maximum because there's an asymptote there. But I can see that at -2, my graph is increasing followed by decreasing, so it must be a maximum. And at 0, my graph is decreasing followed by increasing, so it must be a minimum. So in your homework for tonight, when you draw those sign charts, this is what you're trying to do. This is what you're looking for on the sign chart. Okay, so another definition that we need, stationary points. A stationary point of a function is a point such that the derivative is equal to 0. Now we have looked at that being a local maximum. We have looked at that being a local minimum, but another thing we need to know is this could be a horizontal inflection. So pause the video at this point, write down those couple of statements so that you have them to use. Okay, so let's look back at this picture. We looked at this yesterday, and I told y'all we would look at this 3 today. So I can see that at -2, the value of the derivative actually exists because I have a solid line. It was increasing and then decreasing, so it's a maximum, which is what I see there, increasing and then decreasing. Again, at +1, there's a solid line, so the value of the derivative is actually equal to 0. It's decreasing and then increasing, so this one must be a minimum. But look right here at 3. It does actually equal 0. I've got a solid line, but my function is increasing and then it increases again. It doesn't change direction there. It's increasing and it keeps on increasing. And that is what we call a horizontal inflection or a stationary inflection. So this is the chart I posted in Canvas for y'all yesterday. We're going to look now at that last line. You can see that in both cases I have a solid line here, which means my function is increasing on both sides of it, or maybe it's decreasing on both sides of it. So we have this idea, which sort of looks like x to the third, or we have this idea, which sort of looks like negative x to the third. This one is increasing on its entire domain. This one is decreasing on its entire domain. But you can see that at this blue point on both of them, the curvature changes. In this case, it's kind of curved in a downward fashion. In this case, it's kind of curved upwards. And this is the opposite. It's curved upwards here, and it curved downward here. So even though it's continuously increasing or continuously decreasing, at that point, something happens. Its curvature changes, and that's why we call it an inflection point. Now, those of you who are planning to go from this class into pre-calculus and calculus will spend a lot more time talking about inflection points. Here in this class, we're just going to kind of introduce the idea. Okay, so here's x to the third that I mentioned with that last one. The derivative of x to the third would be 3x squared. So if I take that and I set it equal to 0, 3x squared equals 0. Okay, let's solve this. Dividing 3 on both sides, x squared equals 0. I take the square root of both sides. I don't have to write plus and minus because there's no such thing as positive and negative 0. So I'm going to get x equals 0. So you can see this actually exists. This is not undefined. So if I were going to make a sign chart, I would put 0 on that sign chart with a solid line. And then I can see that on the left-hand side of 0, the function is increasing. So the value of my derivative on that side is going to be greater than 0. It's positive. The function is increasing. And then once I move over to the right-hand side of 0, well, the function just keeps on increasing. So the value of the derivative hasn't changed. It's still positive because the function is still increasing. So this is called a horizontal inflection, or you might see it spelled with an X. In the US, we generally spell it this way. Other countries are going to spell it that way. But a horizontal inflection where it changes its curvature or it changes its shape. And again, you can see that downward kind of curve here and an upward kind of curve here. Okay, the last thing we need to talk about, the global maximum and minimum. We mentioned this the other day. We haven't really done a whole lot with it. So when you're looking for the global maximum minimum, it's important that you also check the endpoints of the graph. So look at this question. It says find the greatest and the least value of this function x to the third minus 6x squared plus 5. Well, I can see that it has a local maximum right here. It's increasing and then decreasing. It has a local minimum right here. It's decreasing and then increasing. But I can also see that it's going on and on forever towards negative infinity here. It's going on and on forever towards positive infinity here. So it doesn't actually have a greatest or a least value. There is not a greatest or a least value on this curve as a whole. There's a greatest value in this little region, that's the local maximum, and there's a greatest value in this little region, that's the local minimum, but not one on the graph as a whole. So what if it said this? Find the greatest and the least value on this particular interval. Well, now that changes things. So let's look at what happens. You guys see, it's a little bit hard to see. I've got my green line right here at x equals -2, cutting the graph off. And I have this purpley colored line at x equals 5 here, cutting the graph off. So as we are looking at this particular function, in between -2 and 5, we are only looking at this part of the curve here, in between those two lines. We have cut it off on either side of that. Well, now I can see that I do have a maximum and minimum for the graph as a whole. Right here is the maximum, right here is the minimum. And if you look at the way this one is phrased, it says, what is the greatest or the least value? But when you ask that question, you're always asking a why question. If I asked you where is the maximum or where is the minimum, where does that value occur? That's an X question. But what is the value is the Y question. So my maximum value is 5. It occurs at the point where x equals 0, but the value is the y, it's the 5. And then my minimum value down here you can see is -27. Again, it occurs at the point where x equals 4, but the actual minimum value, that y coordinate or that y part of the coordinate, is -27. So sometimes it'll be actually at the endpoints, but you can see in this case, positive 20 is definitely not as high as, I'm sorry, -20 is not as high as positive 5, and -20 is not as low as -27. Oh, but look over here, -27, -27. So in this case, my minimum value occurs in two different places. It occurs where x equals -2 and also where x equals 4. So I end up with two minimum values and one maximum value, but notice that my value itself can only be one value. My -27 is the lowest value of this. It happens to occur in two places, where x equals -2 and where x equals 4, but the value stays -27. I can only have one biggest and one smallest. Okay, so at this point, you can finish your section 7.4 worksheet. Be sure you get that turned in by midnight tonight. I will post the answers as soon as I get everybody's worksheets, and then we will discuss them on Monday. So I will plan on seeing you guys Monday. We'll also practice this idea a little bit. I think the sign charts especially are a little bit tricky for you to get used to, so I think it would be valuable for us to spend some time going through some together. So if you just want a little bit of extra practice, even if you get all the ones on the homework right, plan to meet me in Zoom on Monday and we'll talk through some of these ideas and practice a little bit as well, so you'll be in better shape when we take our Topic 7 test.